And sand is one of the things that we could use to put out fires. So sand could be used, we could also use water, we could also use carbon dioxide. Well, let's just have a look at this. We're going to start a fire now and see if we can put it out using some carbon dioxide. Okay, so here is some petrol. We're going to set light to this. Okay. And use carbon dioxide to put it out. So carbon dioxide is very good at putting out fires. Well, is it good at putting out all fires? Let's have a look. The tank over here is filled with carbon dioxide gas. Now, carbon dioxide is heavier than air. Heavier than air, so this tank is filled with carbon dioxide, and it should put out a fire. So I'm going to put into this some petrol, some cotton wool soaked in petrol set alight, and it should be able to put it out. Okay. So here we are, burning petrol into the carbon dioxide. And it's gone out. Let's try that again. So carbon dioxide is heavier than air, so it's staying in the tank. But as soon as I put the burning petrol in, it goes out. Now, could this be used to put out burning magnesium? Well, let's try it. So I have some magnesium here. And I'm going to set this on fire and see if we can put this out in the carbon dioxide. So here the magnesium is burning, and lower it into the carbon dioxide, and actually it's burning even more vigorously than it did before. And if I put in the burning petrol, it's still put out, but I can't light my petrol on the magnesium. So the petrol will not burn in the carbon dioxide, but the magnesium will. Okay? So carbon dioxide is very good for putting out fires that form carbon dioxide or water, but it's no good at putting out the magnesium. Well, what's happening here? If I reach in and take this out, well, you see a lot of smoke forming on the surface here. This is magnesium oxide. And if we look at what's left, we see some white magnesium oxide, but deep inside here, there's a lot of black, and this black is carbon that's been formed when the magnesium has stolen the oxygen from the carbon dioxide, so forming magnesium oxide and leaving behind carbon. So we can show this with a chemical reaction, a chemical equation here. So this has magnesium reacting with carbon dioxide, so Mg is the magnesium, carbon dioxide reacts together to form magnesium oxide. The magnesium steals the oxygen from the carbon dioxide, leaving behind the black carbon and also releasing energy. So the magnesium burns in the carbon dioxide. So we can't use carbon dioxide to put out burning magnesium. Well, could we use water instead? Right, now we're going to try this. We've got a beaker of boiling water here, and I'm going to light some petrol and put this into the beaker. Well, before it even gets into the bottom of the flask, haven't even put it into the water yet, the steam has put it out. So even the steam puts out the burning petrol. What about burning magnesium? So I need to light the magnesium to get it going. Going to get it going, get it burning. Okay, and lower it into the steam and into the water. And look how vigorous the reaction is. So even in water, the magnesium, well, it burns in water. This is combining with the water, it's stealing the oxygen from the water, forming, again, magnesium oxide and, well, giving out hydrogen. So we can show this with a chemical equation. We have magnesium reacting with water. The magnesium steals the oxygen, forming magnesium oxide, and forms hydrogen gas. What else could we try to put out our burning magnesium? Well, we could try sand. So we're going to see now if we can, if burning magnesium reacts with sand. Sand is silicon dioxide, and in this tube here I have magnesium powder and silicon dioxide. I have normal sand, and see if this can put it out. What do you expect? Okay, now this takes a little bit of time for the reaction to start, before the magnesium burns. And we're trying to see if burning magnesium reacts with sand. Okay, so I say this will take a little bit of time just to get it hot enough. But once it's hot enough, we want to see if there's any reaction. Okay, so just warming it up. It's beginning to go. Okay, there we are. It certainly did react. In fact, half of it's all over my safety screen. So even sand reacts with burning magnesium. Okay, now, what do we get when this reacts? Magnesium and sand. So the magnesium steals the oxygen from the sand or the silicon dioxide and initially forms silicon and magnesium oxide. But the silicon that's formed here can react with more magnesium, and it forms magnesium silicide. Now, this was the substance that we had in the tube here that's still crackling away, forming silane gas as the bubbles come into contact with the air. And we should be able to show this. I'm going to take the test tube that we've just heated up and smash it up. Okay, and then tip this into some acid. Yep, thank you. And we should be able to see some of the crackling that we had before. So if we just have the lights down, please. Okay, again, this is forming silane gas, SiH4, and this, as soon as it comes into contact with air, spontaneously catches fire, as we see there. Okay, now then,